Hello everyone. I'm happy to be able to present Chapter 7 to you through a narrated PowerPoint presentation. I am going to convert this to a video and then upload it to YouTube so you can watch it almost in a movie form. I will also post just the PowerPoints for you, so you'll be able to print those off and kind of go through them the same way you would if you were sitting through an actual lecture. I want to let you know that I'm pretty easy about what you are required. I do require you to do the reading, but the only thing I'm requiring you to read is what I discuss in the PowerPoints. So there are a couple of the bacteria that were mentioned in Chapter 7, and I did not highlight them because I kind of felt they weren't something of significance. So you will not be responsible for reading those particular bacteria, but the bacteria that we talk about in the PowerPoints, I will ask you to make sure that you do read them. And remember, this is just kind of an overview of what's in your book. And the book does explain things a little bit more for you. So that's what you will be responsible for on your tests as well. So if I didn't talk about a particular organism, then you will not be responsible for that on your exams. And I also, before I get started, I want to say that I'm really excited to have had contact with many of you throughout this semester, and that I've met new people that aren't within the Allied Health program, that are within other disciplines within Batante Health and Human Services. So it's been nice to have interaction with you as well. So to begin our semester, to begin our PowerPoints, the first thing we're going to talk about is zoonosis. And zoonosis really is something that is spread from animals to humans. So most of our organisms that we have out there are spread from one species to another. So animals to animals or humans to humans. However, there are particular organisms that can be spread from animals to humans. Not humans to animals, but animals to humans. So that's why it's really important when you are, if you are out in the wildlife at all, if you're a hunter, if you like to rescue animals or whatever, a lot of these animals, non-domesticated as well as domesticated animals, do carry infectious diseases. So it's something to kind of be aware of, and I think this will kind of bring a lot of it to light for you. The arthropods are basically insects that carry disease. Okay, and a vector is something that lives, kind of sucks its nutrients from the original organism. And also, we like to say that most of them are parasitic or parasites that live on another species. So if they didn't have that original species, they couldn't exist. And that would be like, for an example, a flea. If a flea did not have a dog to live on, to live off of its blood, then the flea would die. It just couldn't live on its own. So that's what we call vectors, and from the vectors we go to parasites or parasitic. And most vectors or parasites obtain their meal of blood from an animal or a human, such as I just used the example of a flea, as well as mosquitoes. If they didn't have humans or animals to live off of, then they would not live as well. They pick up infectious microorganisms and later infect another animal or human by inoculation, meaning by injection. So the same, going back to the mosquito. So if a mosquito bites a dog that has heartworm, it can carry, and it feeds off of it. it can carry that blood through its little spout to go to another dog and bite that dog, and when it bites the dog, it injects that little bit of blood that it's carrying with it into the other dog. The other dog will get heartworm. So that's kind of what we're talking about when we say inoculation. It pulls from one, it carries it and takes it to the other, and then it basically injects it into the other. Some of the arthropods act only as mechanical carriers, meaning it carries from one area to the other area. They're not true reservoirs. They don't actually engulf and have like a reservoir of blood, because the vector does not maintain the organism. So what we're saying by that is the vector, meaning the one who takes the blood, doesn't live, so to speak, in that vector. It just carries it from dog A to dog B. It doesn't live in that, say, the mosquito, going from dog A to dog B. It just carries it. Other arthropods become reservoirs for an organism if it infects them and is able to develop and multiply. So what we're saying here is that some of them do actually live in that particular organism. So when we go on and we talk a little bit more about some of the diseases, you'll see what I'm talking about how they actually live and multiply in the reservoir, say maybe a rabbit or a squirrel. Rickettsia. Rickettsia comprises a group of microorganisms that phylogenetically occupy a position between bacteria and viruses. And these little microorganisms can be as small as a large virus, and they live within the cell membrane. They are non-motile, meaning they don't move around at all, which would make sense because they're living within that little cell membrane. Gram-negative. We know that our bacteria are either gram-negative or gram-positive. These little guys are gram-negative. They do not form spores. They are highly pleomorphic, which means that they can change the way they look or how they present themselves. So they can present themselves as the shapes of all the different bacteria. So we know from microbiology that we have shapes that are cocci, rods, which are our bacilli, spirochetes. So these little guys can present themselves as one and then transform themselves into another shape. In this chapter, we'll discuss the zoonotic diseases caused by bacteria and rickettsia, and acquired most often through the skin and mucosa. The viruses we will talk about in the next chapter. So right now we're just looking at rickettsia and bacteria and how they are transmitted through skin and mucosa. So first we're going to talk about Lyme disease, and I'm sure most everybody has heard about Lyme disease. It was first identified in 1975 in Lyme, Connecticut, which is up on the eastern coast, and it is tick-borne, spirochetal, and zoonotic. It's been reported since then in every state except the state of Montana. We used to think that it was just on the East Coast, but now we are all subject to being infected by by Lyme disease from ticks. The spirochete is Borrelia Bergdolfi, and primarily you are going to see the tick live on deer, wild rodents, and other wild animals. Primarily, we always talk about it being a deer tick that lives, it can live on any wild animal such as rabbits, squirrels, rats, but up on the eastern coast where this first was transmitted, they primarily had a lot of deer out in the woods, and that's where they had determined that that particular tick lived. Incubation for Lyme disease is anywhere from 3 to 32 days after being bitten, which you can see there's a large time frame in between that an individual may not even remember being out in the woods, let alone being bit by a flea. Immunity does not result from one infection, meaning you can get Lyme disease more than one time. So it's not like an inoculation or a vaccine where once you get it, you won't, once you get the vaccine or once you've been exposed, you won't get it again. This particular disease you can get over and over again. The highest rates are going to be in children between 5 and 9, in adults over 30, and remember that's going to be because the individual's immunity is very susceptible from 5 to 9 and also over 30. And in the United States, in the last slide, I said that we named that little tick a deer tick because it was most often seen on deer up on the eastern coastline, but we now know that the most common reservoir for Lyme disease is going to be the white-footed mouse, and if you notice, that's also going to be an indication that we have these little white-footed mice all over the United States. So, and remember, mice can be anywhere, as with deer, we're not going to see deer in the inner city. We're going to see mice in the inner city areas. So that's going to be the most prominent reservoir in North America for Lyme disease. And as we have said already, transmission comes from the bite of the infected tick. The spirochete transmission can go from pregnant mom to the fetus, and there is no indication at all that one human can transmit Lyme disease to another human. The symptoms of Lyme disease, and the reason we're spending a little more time on Lyme disease is because it is so much more prominent, and we do see it quite a bit in the United States. The early stages are minimal. A lot of people don't even remember even being bitten by a flea, or I'm sorry, a tick, or seeing the tick. So, like I said, that ends up being a problem when someone is sick or has symptoms, because something could have happened a month before, and it's difficult for the individual to remember that. The one thing that they do see with Lyme disease within the first stage is a very distinctive lesion called erythema migrans, and it can be a macule or a papule, and they always like to refer to it as a bullseye, because what ends up happening is there's this little papule in the middle, and then you get a very distinctive clear area around that papule. Then around that is another circle. And so if you can envision a bullseye, that's kind of what it looks like. And as you see that bullseye in that red area on the outsides continue to grow, that is the progression of the disease. A lot of individuals just kind of feel, really tired. They have a headache, they're fatigued, they have a stiff neck, their muscles ache. And as the disease, they do have some aching in their joint. As the disease progresses, they get a lot of aching in their joints. That rash can go along with the papule or the bullseye. The bullseye infection that is very distinctive for Lyme disease. And also they get swollen lymph nodes. After the very beginning stages where you get that bullseye or the erythema migrans, they can end up with a dry cough and a sore throat. But as you see, a lot of these symptoms are very typical of having the flu. So what ends up happening is when they don't get better and then this disease continues to progress, then they start with the joint problems. Then that's usually when they can make a complete diagnosis on the individual that they have been, infected possibly with Lyme disease. In stage 2, which can be weeks to months later, they start to have neurologic abnormalities, tingling, numbness. They can have cardiac abnormalities with irregular heart rhythm, PVCs. So that's, kind of, once again, if you look at what those symptoms are, they can mimic a lot of other symptoms. But then once we get into stage 3, like I had said earlier, as that disease progresses, they start having swelling and pain in other large knees and large joints. And that's because the infection has spread to those joints and kind of made its home there. So that's usually when they start, if they haven't been diagnosed earlier on, this is when they start to realize that there's something really serious. So it's a slow progression. It may lead to chronic arthritis or fibromyalgia. Fibromyalgia, we know there's no cure for it. They do treat symptoms for it, and that's just kind of like where your body, everything on your body hurts, but there's really no actual physiological reason why this individual's body hurts. The treatment for it is curable. It's usually long-term antibiotics, and the best idea for an individual who's working outside in high weeds, or someone who's an outdoorsman or someone who likes to hunt, is prevention. And that means covering yourself up, making sure you have long sleeved shirts on, long pants tucked into boots so that no fleas can jump in there. And I don't know why I keep saying fleas, ticks, probably because I have 2 dogs and 4 cats, and so fleas, what really comes to my mind is I'm always worried about fleas in the summertime. But ticks, to prevent the tick bite. And the other thing, talking about dogs and cats, is if you do have outdoor animals and you have woodsy area around your house, you are going to always want to make sure that you inspect your animals for any ticks as well. Now, my particular animals, and I'm sure most of you, if you have them, they're on flea and tick medication, which, in the past 10 years, we have this now as a primary prevention for our animals. So we don't want them to get bit. We don't want them carrying anything on them. And that's a big public health issue in itself, is to make sure that individuals' animals are on flea and tick medication for prevention. And I will tell you just a little story that I have we have a lot of woods around our house. We live in a development, but it's surrounded. Everyone's backyards are woods, and there's no houses behind us. And we moved here about a year ago, and like I said, my dogs are on medication. My cats don't go outside. They're on medication. But probably, I would say maybe like November. I was petting my one dog. I have a 12-year-old corgi, and I was petting him, and I felt this little bump on him, and he kind of jumped away, and I thought, oh, well, maybe he scratched himself or whatever, and it's a scab. I'll check it. And I kind of forgot about it, and about 2 weeks later, I was petting him, and I came across this bump again. And so I made him lay down, and I pulled the fur back, and what fell off but a dead tick. And it had burrowed its head into Thayer's. It was on his side, actually, and there was a hole in there. And it was, once I made sure that I had removed the entire tick, then, of course, I cleaned the area, and every day I cleaned it until it healed, which was probably a good month. But he had a little hole in there where this tick had burrowed in, and he's on the pill that they take once a month for heartworm, fleas, and ticks. So, and I'm religious about it. So, I mean, it still can happen. That's why it's really important that you do inspect your animals to make sure that they haven't picked anything up. And truly, I should have been a little bit more adamant about checking him, but I think the tick probably had gone in there, once it got into his flesh, got the medication, and it just died. But still, you can see how that could be, a public health risk for you and for your animals. So that was just a little story I threw in there for all of you to bore you. But, yeah, it is very important with animals. And once you kind of see this, like, you start thinking, oh, gosh, I don't want any squirrels by my house. I don't, the rabbits are really cute running through my backyard, but you know what? I don't want them anywhere near my house. So once you start reading some of these things and how easy they're transmitted, it makes you much more aware of your surroundings. Okay, so next we're going to talk about Rocky Mountain spotted fever. And we have pretty much heard about that through the news. We don't really hear too much about it in the state of Ohio, for those of you that live in Ohio. This is something that really got its name from the Rocky Mountains, obviously. And Rocky Mountains are they're down North Carolina, coming up through the eastern southern seaboard area. And it is a typhus infection, which is an infectious disease that's called by rickettsia, and characterized by a purple rash, headaches, fever, sometimes delirium, and historically can cause a high mortality during wars and famine. And we will talk more about that when we talk about typhoid, but typhus is a form of typhoid. There are several forms of the typhus infection, and they are usually transmitted by a vector, and vectors such as lice, ticks, mites, rat fleas, and Rocky Mountain spotted fever is found throughout the United States. However, like I said, you will see it more on the eastern southern seaboard. The infectious agent is Rickettsia rickettsiae, which is the reservoir of infection is in ticks. It can be fatal without proper treatment. The incubation period is 3 to 14 days. Once again, it is not spread from person to person. And once you have had Rocky Mountain spotted fever, you will never get it again for your life. One attack maintains immunity for life. Transmission: the tick needs to be attached for several hours before the rickettsia becomes infective. Individuals can become infected if they crush the tick, and they get the tissues or the feces of the tick are rubbed into the open wound where they have been bit. They can also contract the disease as well. So it doesn't have to be on there for several hours. So if someone would see the tick and they would smash it, and once the tick has broken the skin, you're still susceptible. The symptoms: fever, loss of appetite, slight headache after about a week or so. Also can be a sudden onset of symptoms as well. It could be very soon after the bite. Half the cases, they develop small pink spots on their wrists and ankles, and then from there spread all over the individual's body, hence why they call it spotty fever. And it is treated as well with antibiotics, and once again, the most beneficial way of avoiding the disease is through prevention, and that's the same as we talked about in Lyme disease with the long sleeve shirts and long pants tucked into boots, gloves, that type of thing. You can refer back to what we talked about in Lyme disease. So next we're going to talk about tularemia. This we see mainly in rabbits and hares. The bacterium is Francisella tularensis, and the incubation period is 1 to 14 days, but most cases it's much sooner, from 3 to 5 days. So you can see, once again, there's a very broad time frame where that bacterium can start to cause symptoms. Reinfection is rare. Generally, if you've had it once, you're not going to get it again. With proper treatment, fatalities are rare. How it's transmitted: humans can become infected by working with or cleaning the skin of infected animals. Fluid from infected flies or ticks or other animals, or by the bite of infected insects, by eating insufficiently cooked rabbit, drinking contaminated water, or from inhalation of dust from contaminated soil, grain, or hay. So if we look at contamination of soil, grain, and hay, rabbits are going to be in the soil. They will be in the grain trying to get grain, or they could be in hayfields. So the dust from any of that has been contaminated with the bacterium, if the individual inhales it, they can become contaminated with it. And also, when they're talking about being an individual being infected by working with or cleaning the skin of an infected animal, a lot of times that doesn't mean a live animal. That means an animal that maybe has been killed or butchered for eating. And if the individual is cleaning it, they can become contaminated. I know this sounds kind of gross, but road crews, people that pick stuff up off of roads, if the animal is contaminated, once again, this can transmit to the individual that's cleaning it up. Insufficiently cooked rabbit, I don't know how many people really eat rabbit anymore. When I was growing up, my father was a big hunter, and whatever he hunted and killed, we ate, and rabbit was one of them. And I think about it now, and when I was young I used to think it was delicious, but I think about it now like, oh my god, I'd probably go hungry before I would eat a rabbit. But that was just the way it was. And I think there's still probably some people out there that hunt and eat what they hunt, but things have changed a lot, and there's a lot more bacterium out there than there was 40 years ago, when I was younger. But if you are a hunter, these are things to keep in mind and take into consideration. The symptoms of the disease is usually an ulcer at the entry point. The individual usually will have swollen lymph nodes, usually close to where the bite was. If it's inhaled, we talked about that already, the individual can become contaminated. Early symptoms are very similar with ulcer, swollen glands. If it's inhaled, the individual will have very similar early symptoms, like the swollen glands and so on, and then it develops into more of pneumonic, meaning pneumonia, or typhoidal disease, which are all the signs and symptoms of typhus and typhoid that we had talked about. If you are eating the contaminated meat, the problems that you're going to have, the symptoms you're going to have, are going to be significant and severe GI issues, usually lower GI issues, vomiting, diarrhea, so on. This, once again, is treated with antibiotics. So next we'll talk about the plague, and I'm sure everyone has read about the plague or heard about the bubonic plague that is very close to, has been very close to wiping out complete cities and towns and countries actually in the past. It's the Bacillus is Yersinia pestis. It's transmitted primarily through rodents, and you do see the plague in western and southwestern United States as well as third world countries throughout the world. And there's really three kinds of plague. There's the bubonic plague, which a lot of people, I'm sure you've heard bubonic plague being mentioned, but not so much the pneumonic or the septic plague. And the incubation period, look how short this is, 1 to 7 days. And without treatment, the bubonic plague is 50 to 60% fatal. So pretty much half to a little bit more than half of people that get the bubonic plague are going to die without treatment. The other two forms, meaning the pneumonic and the septic plague, are pretty much 100% fatal without treatment. So, when anything goes septic on an individual, your chances are pretty low of survival. It basically means that it has traveled through the bloodstream and has infected your entire body. So recently, this is kind of off the beaten path, but when I lecture in classrooms, I love to tell these stories. So recently, my fiance, his best friend, was undergoing treatment for radiation treatment for colorectal cancer, and he was doing well, doing fine, having no problems, and within like a 2-day period, he was sick, and the infection that he had acquired went through his body in the form of septicemia, and he went into cardiac arrest, and he died, and he was 52 years old. They're both police officers, very healthy and in great shape, took really good care of himself, but that's just how quick, when something goes septic, it is, it's a huge concern, and individuals really don't have that much time to get treated. The transmission of the plague is going to be a flea bite from usually rats, squirrels, prairie dogs, hares, and it can also be a domestic animal. So once again, this is just a flea that has been on one of these animals that is carrying the plague. The tissue of an infected animal you can be contaminated from. It can go airborne and be inhaled, obviously, hence being the pneumonic form, and also improper handling of lab cultures. So even cultures that we're not sure the individual has the plague, if you're looking for something else and you haven't tested for plague, this particular individual can still possibly have the plague, and you're dealing with their lab cultures, and if you're not dealing with them properly, you can become contaminated as well. So the symptoms will include swollen lymph nodes, which can become huge, like as big as they describe them as chicken eggs. And they can have them in their neck, their armpits, their groin. That's where the most prominent lymph nodes are at. And within those lymph nodes, they will start to hemorrhage, and those lymph nodes then will get very dark, almost black, and that's where the nickname for typhoid, we'll call it the Black Death, because if you would get these lymph nodes that would be swollen like that and they would turn black, you would know pretty much that you had the disease. And they're obviously going to be tender and warm, tender because they're huge, and warm because of the influx of blood to the area. You can also have fever, chills, headache, fatigue, muscle aches. It's a really horrible death. Primarily you will see these, like I said, in third world countries, and actually you kind of see these episodes where I hate to say in poor areas, but yes, in poor areas, because when famine strikes, when there's no food for the animals, then the animals come closer into humans, and when the animals die, like the rat dies, then the flea jumps off, and then they bite humans. So that's how it will spread so quickly, because you think about having one rat and how many fleas could live on one rat and it dies. We'll think of having maybe 100 rats in that area, or 500, and so that's how they will progress. And you can also see how, like I said a few slides earlier, how it can wipe out a whole community or a whole city, and why it was so feared back in the 1800s, because we did not have antibiotics at the time to treat it. So if the bubonic plague or the plague came through a town, it was pretty much going to kill most everybody. So now we do have treatment for it, but remember how contagious this disease is. I mean, it can spread from one mouse, like I said, one mouse, 500 fleas on this mouse or this rat, and jumping off and biting one person and biting another person and contaminating it. So it was a very bad disease in the 1800s especially. Penicillin does not work on it. Streptomycin is seen to be the most effective, and streptomycin is a aminoglycoside antibiotic, which is a totally different generation of antibiotics, and it is I say most effective in its broad spectrum. Broad spectrum means it covers so many different shapes of cells that are living. So When you have something that the doctors really aren't sure what it is, a lot of times they're going to give you an aminoglycoside that is broad spectrum, so it covers a lot of different bacterias. The treatment for the bubonic plague must begin within 8 to 24 hours of onset. Within 18 hours for the other two types, the pneumonic and the septic form of the plague. So next we talk about leptospirosis, and the spirochete is Leptospira. When an individual gets this disease and it's very severe, they call it Weil's disease, and I believe that is named for a German scientist possibly who actually isolated that spirochete, I believe. Don't quote me on that. Weil's disease is an acute infection in which the organisms localize in the kidneys, producing kidney dysfunction, so causing kidney failure, actually. The spirochete can spread through the blood to other parts of the body, so it can go to the heart, it can go to the liver. The liver is the most common, second to the kidneys, that's affected with it. And that's hence just where the anatomy of the body is at. The reservoir is in domestic and wild animals, including rats. Usually start to see symptoms. In about 10 days, you'll start to see some symptoms of the disease, and you or the individual may excrete the disease for up to 11 months. So remember, this is spread through it localizes in the kidneys. So when the individual urinates, that urine is contaminated with leptospirosis. So think about wild animals outside that are contaminated with this, and they're urinating throughout your backyard or throughout your garden, and then that can live in the soil as well to continue to contaminate people. Once you have this, you have immunity, so you probably will never get it again, or an individual probably will never get it again. Transmission is contact of the skin, especially with an open wound of any sort, and that can be from water, moist soil, or contaminated vegetation. And remember, I said before that, think about having a wild animal that is contaminated running through your garden, and your vegetation or whatever you're growing could be contaminated with this bacteria. Also, in the rain and the water runoff, it runs off into ponds and open springs. A lot of people like to go to. They have certain areas that have open springs that supposedly is spring water and it's healthy and so on. It can be contaminated because if that rabbit or that particular animal has urinated in that area, then it contaminates the water. And so sanitation workers who work with a lot of water, farmers who are working out in fields, and there usually you'll see cases pop up every now and then where a kid has been swimming in a pond, a local pond. And I know growing up, of course this wasn't probably really known back then, but my grandparents had a huge farm. They were farmers, and they had a pond, and we always wanted to go swimming in that pond in the summer, and my grandparents would never let us. And they would say there were germs in there, not realizing that, what actually could have been living in there. So that's a lot of times when you'll see a child infected when they've been swimming in a pond or a creek where the water runoff has gone into it. And your treatment for this particular disease is going to be antibiotics, and penicillin is effective, so it's usually going to be your drug of choice. Next, we're going to talk about brucellus. It is the Bacilla brucella abortus, found in cattle. So these are the little things you're going to kind of want to remember when we talk about the different, on our tests. If I ask you what bacteria is primarily found in cattle, you're going to know what it is. And the same with the other. We talked about typhoid being primarily carried by mice or rats, so you should know those. And then you can always use your PowerPoints that you're able to print when, and you know how I am by now, that when we do have an exam, I don't care if you use your notes or your books. It's fine. My goal is for you to learn, not to make sure that you didn't cheat. I want you to learn. That's more important to me. My goal is to see successful students. So, like I said, if you print these out, you'll be able to follow through with our exams as well. People are contaminated with brucellus through drinking contaminated milk. Individuals that work in slaughterhouses that butcher cattle for grocery stores or for commercial use, and also from contaminated barn dust. The next bacteria we're going to talk about is tetanus, and the bacterium is Clostridium tetani. This particular bacteria is found in the intestinal tract of humans and animals, and also found in soil. It is introduced through a wound with the right conditions. It multiplies through spores, and they begin to multiply, and then they produce an actual deadly toxin that kills or makes the individual really, really sick. Meaning, when I said the right conditions, it has to be a anaerobic condition for tetanus to live and to be able to multiply. So I know all of you have probably heard of tetanus. You've all had your tetanus shot. When working in the healthcare field, you would have to have it. And there is a vaccination for it, which is the best measure. Once again, I remember when I was younger and I was on my grandparents' farm, we were never allowed in bare feet. I stepped on a log one time that had a nail in it, and the nail went through my tennis shoe and into my foot, that was the first thing. My grandparents took me to the hospital for a tetanus shot, because tetanus is very scary when you would live or work on a farm. So now pretty much all children have their tetanus as part of their infant and toddler vaccinations. And then I believe it's once every 10 years now you are required to have another inoculation. The fatality rate for tetanus is 30 to 90%. As the patient gets older, they're more susceptible. As the patient gets older, they are more susceptible and less receptive to inoculation, so they don't work as well as you get older. So that's why we inoculate as a child, and the body of a child, it accepts the inoculation much better. I'm sorry, that That's my email that keeps going off. It accepts it much better. As you get older, that particular, your body loses its ability to hold immunity to particular vaccinations. And one of the diseases that is associated with tetanus is lockjaw. I'm sure many of you have heard of lockjaw, and that really has to do with the rigidity of the muscles and the nervous system that happens when this bacteria takes over the body. And the last bacteria that we're going to talk about is anthrax, which I'm sure once again everyone has heard of anthrax, and if you were around during the Persian Gulf War, that was a huge area of fright for a lot of people that Saddam Hussein was going to use anthrax to as biological warfare to contaminate the United States or the soldiers that were fighting in over in Afghanistan and Kuwait and in Iraq. So this bacteria in particular was the first human bacteria that was ever identified, and it was identified by Robert Koch in 1876, who, if you have had microbiology, he is a very prominent person in microbiology. He's considered like the father of microbiology because he has been associated with isolating anthrax, TB, I want to say cholera, which obviously has saved a lot of lives. He's a very prominent person in microbiology. Individuals that process animal products, farmers, veterinarians that work directly with infected animals, those are all people that are susceptible for anthrax. The scary thing about it is the spores can survive for years after the animal has died, and they continue to live in basically the carcass of the dead animal. So hair, fur, it lives in the soil because the carcass is buried, the hide of a dead animal, wool. So that's what's so scary about it. And when you think about a spore being, obviously airborne, and it being as fatal as it is, it definitely is something that could be used as a biologic warfare weapon. With anthrax, the death rate is about 99% after the individual has been exposed. And I will clarify that and say someone who has not been vaccinated for anthrax, the death rate is about 99% after they've been exposed. It is the most feared biological warfare weapon, and the transmission of anthrax is through the injection of contaminated food, cutaneous or inhaled. The symptoms of anthrax are itching at the site of entry. Within a day or maybe a little bit more, you end up with a papule. Then a day or two, it turns into a vesicle. And meaning the papule meaning there's just a little small red spot, and then the vesicle means it's open. So in a few days, it gets larger, it turns black, and then it's a pustule, meaning it's filled with, obviously, pus and bacteria. And then if you want to Google and see what an actual lesion looks like, the ulcer gets greater and greater in size, and that ulcer is caused by the toxin that's growing within that sore. And it's a really nasty, scary looking disease when someone actually gets it. Penicillin is going to be your drug of choice for anthrax. And most individuals that are at high risk, meaning individuals that are going to be working with, the hides or these particular bovines or cows or whatever that are susceptible for the anthrax, they are recommended that they have a vaccination against it. So that's going to be your best measure of prevention. So it's not something that's super, obviously not common, but if you're working around animals that could potentially be contaminated, the recommendation would be for a vaccine. Okay, so that about does it for Chapter 7. And if you have any questions or you don't understand, I think it's pretty straightforward. I think it's really interesting. I was a microbiology minor, so of course this is interesting for me. I hope you guys found this interesting as well. And like I said, any questions, just let me know.